Bismillahirrahmanirrahim. Assalamu alaikum. My name is Uzaffan Ozbajwa and I am from the Department of BS Chemistry and my ID is 007. I'm here to present my presentation and my topic of presentation is oxygen isotopes in geology and mixed metal oxides. So moving toward the first half of my presentation, that is oxygen isotopes in geology. So first of all, we should know about isotopes. So what are isotopes? Isotopes isotopes are the forms of element or species that have the same atomic number but different mass number. As we know, the nucleus, as we know, the mass number is composed of proton and neutron. So the difference arises in the neutron number. So when a species have greater number of neutrons than the proton, then we result an isotope. So coming towards the isotopes of oxygen, although we usually consider oxygen atoms to have 8 neutrons, that normal oxygen 16 have 8 neutrons there, but there are in fact two other stable isotopes of oxygen element. The isotopes and their relative abundances are shown in the table. First of all, oxygen A16 has oxygen 16 isotope that has a relative abundance of 99.763, and the second one is the oxygen 17, which has 9 neutrons and its relative abundance is 0.037, and the third one is oxygenating, which has 10 neutrons and has a relative abundance of 0.200. So, thus, an oxygen atom in every 500 atoms has a mass that is greater than that is 12% greater than the other 499 elements or atoms. So, this heavy oxygen will have slightly different physical properties, such as it has different vapor pressure, different melting point. It is accept both as the element and in its compound. In particularly, water molecule containing oxygen 18 isotope of oxygen has a vapor pressure significantly lower than that of oxygen 16 containing water molecule. This is because oxygen 18 isotope of water have greater mass than the oxygen 16 isotope of water. So the vapor pressure is lower for oxygen 18 water molecule. Hence, in an equilibrium between liquid and gaseous water, the gas phase will deficient in oxygen 18, as I told in the previous point that the oxygen 18 containing water molecule have lower vapor pressure, and that's why it is deficient in the gaseous state. So because the most evaporation occurs in tropical waters, those water will have a higher concentration of oxygen 18. This is again inconsistent with the vapor pressure of the water containing oxygen 18 isotope. This increased proportion of oxygen 18 will be found in the marine equilibria that involve oxygen. We can use the ratio of the two isotopes of oxygen, that is oxygen 18 to oxygen 16, to determine the temperature of the scenes in which shells were formed millions of years ago, simply by determining the oxygen isotopic ratio in calcium carbonates of the shell. So the ratio of the two isotopes, oxygen 18 and oxygen 16, is used to determine the temperature of the seas. So the second part of my presentation is mixed metal oxides. So mixed metal oxides are compounds that contain one or more different kinds of metal cations. Means oxides can be binary, tertiary, or quaternary, depending upon the presence of different metal cations. So they can be further based on whether they are crystalline or if they are crystalline need mixed metal oxides. So we can determine the oxide composition in them. The different metal cations are present as polyhydra, which are connected in various possible ways, such as corner or edge sharing of chains, etc. So here are different compositions of the mixed metal oxides as shown in the diagram or picture. So if we move toward the synthesis of mixed metal oxides, there are various methods for the synthesis of mixed metal oxides, which include sol gel technique, wet impregnation method, mechanochemical synthesis, hydrothermal method, co-precipitation method, and the last one is the microwave irradiation. So we will study the most commonly used and widely used technique for the mixed metal oxide synthesis, that is the sol gel. So it is a hydrolytic polycondensation of a stoichiometric mixture of components in a certain ratio, followed by the thermal post-treatment of the gel so formed, yielding the desired product. So here is a schematic diagram of the sol gel method, in which we have a solution of precursor which is formed by the tools which is formed by the hydrolysis. Basically, the sol gel method consists of two steps. First one is the hydrolysis, and second one is the polycondensation reaction. So the components usually the metal alkoxide ions and the solvent is hydrolyzed to form the solution of precursors, which is condensed to form the colloidal solution. The colloidal solution is further condensed to form the gel, and the gel is dried depending upon the application of the gel in different fields. So it is dried on the basis of its application. So it after the gel has been dried, it is converted into zero gel, which is calcined and grind into powder. So calcination is a process in which the material is heated at high temperatures in the absence of oxygen, usually below its melting point, in order to remove all the impurity, in order to remove impurity or volatile substances. So the powder is then pressed into pellet, and the pellet is sintered into the final product. So the sintered process is the sintering is a process in which coalescing of a powdered material into a solid or porous mass by means of heating without liquefaction occurs. So the final product is characterized by the same XRD or several different techniques. So mixed metal oxide compounds. First one is the spinel. Spinel itself is magnesium aluminum oxide, but of more importance are the enormous number of compounds that adopt the same crystal structure as that of the magnesium aluminum oxide and are characterized under the category of spinel. So they have general formula A, B2, X4, where A is usually a dye-positive metal ion, B is usually a dye-positive metal ion, and X is a dye-negative anion, usually oxygen. So here is a diagram of the framework of unit cell of spinel, which consists of 32 oxide ions in an almost perfect cubic closed-packed arrangement. So the unit cell composition is usually A8, B16, and oxygen and O32. So if we study the unit cell of spinel, it consists of oxide ions that from the face-centered cubic array. Face-centered cubic array. So these are the faces. If I told this one is the whole face, as so the oxygen is present at the center of the phase. So the oxygen is present at the center of each phase, and there are octahedral sites at the center of the cube, and in the middle of each cube edge. So the octahedral site, this one is the octahedral site, and it is present on two locations. First one is the center of the cube, that is center of the cube here. This one is the cubelet center, and it is present at the center of the cube. And the second one is the middle of edge of each cube. So this one is the middle of the edge of each cube. So it is present, the octahedral site is present at two positions. First one is the center of the cube, and second one is the middle of the edge. And the third site, that is the tetrahedral site, is located in the middle of each cubelet. Suppose this one is the this one hole is the cube, and this point, this one is the cubelet, and this one is another cubelet. So the octahedral site is present in the center of the cubelet. This one is the octahedral site. So the second one is the perovskites. Perovskites has the general formula APO3, where A is that usually a dipositive metal ion, and B is generally a small tetrapositive metal ion, and O is the oxygen. In perovskite, the parent compound is calcium titanate or calcium titanium oxide. That the crystallity consists of independent calcium positive two ions, titanium positive four ions, and oxygen di-negative oxygen ions. So the large calcium ion occupies the center of the cube, as I told in the previous compound. The large calcium ions occupy the center of the body. So this is the structure of the perovskite unit cell, and the center of the unit cell is consists of the calcium ion. It is surrounded by 12 oxide ions. So a calcium ion is surrounded by 12 oxide ions. These are first one, second one, third one, and so on. Each eight titanium ions are located at the at the cube corners. So this one is the titanium ion that is located at the corners, and there are eight titanium ions, four on the upper corners and four on the lower corners. Each has six oxide neighbors. This one, so suppose this titanium ion, it has three neighbor oxygens, first one, second one, and third one. So the three coming in the second cubelet that is located below it, being in the adjacent unit cell. So this is all from my side. Thank you.